close your eyes for a moment. Actually, don't. Keep them open. Because right now, light is hitting your eyes at 186,000 miles per second. Cells in your retinas are converting that light into electrical signals. Those signals are racing through your optic nerve, crossing synapses, activating neurons across your visual cortex. And somehow, you see, not just raw data, not just patterns. You actually experience the color red. You feel the warmth of a memory. You sense the weight of a decision you haven't made yet. Here's what keeps me up at night. There's nothing in the laws of physics, nothing in chemistry, nothing in biology that says 100 billion brain cells firing should feel like anything at all. Think about that. Your toaster processes electricity. Your thermostat processes temperature. Your computer processes billions of calculations per second. They don't feel anything, so why do you? The neurons in your brain are made of the same atoms as the neurons in a dead brain. The same carbon, hydrogen, oxygen, nitrogen, the same quarks and electrons following the same physical laws. So what's the difference? Why does one configuration produce experience and the other doesn't? And yet, here you are, aware, listening, wondering. What if consciousness isn't supposed to exist? What if awareness is an accident, a glitch in the system of the universe that was never meant to happen? And what if something is about to notice? Welcome back to Code, Cosmos, and Chaos, where we drag the biggest questions of existence into the harsh light of a code review. I'm Chris, a software engineer and security architect with 25 years building and breaking complex systems for one of the top 100 companies on the Forbes Global 2000. I hold a computer science degree from Florida Atlantic University, and I've spent my career hunting bugs that shouldn't exist, patching security holes that defy logic, and watching unexpected behaviors arise from systems that were never designed to produce them. Last episode, we asked whether we're living in a simulation. Today, we go deeper. We ask, why do we experience anything at all? This is what philosophers call the hard problem of consciousness, the question that has brilliant minds tearing their hair out for decades. And I think my background in software gives us a lens that philosophy alone cannot. Because I've seen it happen in my work. I've watched simple rules produce behaviors no one predicted. I've seen systems do things they were never programmed to do. And sometimes, those accidents look almost intentional. So let's ask the dangerous question. Is consciousness a built-in feature of the universe? Or is it more like a hack, an unintended shortcut that was never supposed to exist? Let's start with the question that breaks everything. In 1995, philosopher David Chalmers stood up at a conference in Tucson, Arizona, and asked a question so simple it's infuriating. Why is there subjective experience? Let me unpack that because it sounds abstract, but it's actually the most concrete thing in your life. Science has made incredible progress understanding how the brain works. We can map which brain regions light up when you see a face, hear music, or feel pain. We can trace the electrical signals from your eyes to your visual cortex. We can identify the neurotransmitters that flow when you fall in love or feel afraid. We're getting really good at the how. But here's the gap. None of that explains why any of it feels like something from the inside. Think about your smartphone camera. When you take a photo, light hits the sensor and gets converted to electrical signals. Those signals get processed by software, turned into data, and stored as an image file. We understand every step perfectly. But at no point does your phone experience that photo. It doesn't see the sunset. It doesn't feel moved by your kid's smile. It's just shuffling data around. Your brain does something similar. Light hits your eyes, signals travel through your brain, patterns get recognized. But somewhere in that process, something magical happens. There's a you that actually sees the image. There's an experience happening. There's something it feels like to be you looking at that sunset. Philosophers call this qualia, the subjective, felt qualities of experience, the redness of red, the painfulness of pain, the taste of chocolate. These aren't just information states. They're experiences. Where does that come from? Why isn't your brain just shuffling data around in the dark like your phone? Here's what makes this the hard problem. You literally cannot find consciousness in the laws of physics. The equations that describe how atoms move, how light travels, how energy transforms, none of them mention experience. There's no formula for what it feels like to taste chocolate. Chalmers distinguished this from what he called the easy problems of consciousness. Things like how we focus attention, how we integrate information, how we report our mental states. Those are still incredibly difficult scientifically, but they're tractable. They're engineering problems. We can imagine solving them with better neuroscience. The hard problem is different. Even if we had a complete map of every neuron and synapse in your brain, even if we could predict every behavior you'd ever make, we still wouldn't know why there's something it's like to be you. It's like consciousness snuck into the universe through the back door. In my line of work, when something shows up that shouldn't be there according to the rules, we call that suspicious. We call it an anomaly. And anomalies usually mean someone found a loophole, a way to make the system do something it wasn't designed to do. Here's where my engineering brain starts seeing patterns. In complex systems, there's a phenomenon called emergence. It's when simple rules, followed by lots of individual pieces, produce behaviors that nobody programmed. Here's an everyday example. A single ant is pretty dumb. It follows maybe a dozen simple rules. Follow pheromone trails, pick up food, avoid danger, turn around when you hit an obstacle. But put 1 million ants together, each following those same simple rules, and you get in colonies that build sophisticated structures with climate control, wage coordinated wars, farm fungus, maintain waste disposal systems, and solve complex logistics problems that would challenge human engineers. No single ant understands the big picture. No ant is the architect. The intelligence emerges from the interactions, or think about a flock of birds. Each bird follows 3 simple rules. Stay close to neighbors, don't collide, fly in roughly the same direction. From those 3 rules, you get those breathtaking murmurations. Thousands of birds moving as one, creating shapes and patterns that look choreographed by a master artist. But there's no choreographer. There's no bird in charge. The beauty emerges from simplicity. I've seen this in my work constantly. You write clean, simple code, you deploy it across thousands of servers, and suddenly the system starts exhibiting behaviors that exist nowhere in the code, cascading failures that ripple in unexpected patterns, spontaneous synchronization between processes that have no direct connection, load balancing patterns that nobody designed, behaviors that seem almost alive. These aren't bugs in the traditional sense. They're emergent properties, behaviors that arise from interactions between parts, not from the parts themselves. The whole becomes more than the sum of its pieces. Now here's the big leap. What if consciousness is exactly this? What if awareness is an emergent property that naturally arises when you have enough neurons connected in the right way? This is where I want to introduce a concept from my security work, the exploit. For those who don't live in the cybersecurity world, an exploit is when someone finds a way to make a system do something its designers never intended. It's using loopholes, gaps between what a system was supposed to do and what it actually does. A classic example. A website has a login form. It's designed to check your username and password against a database. Simple, right? But a hacker discovers that if they type a certain sequence of characters, something like or1, They can trick the system into letting them in without a valid password. The system's designers never imagined anyone would input that specific sequence. The hacker exploited the gap between the design and the reality. Another example, buffer overflows. A program allocates a certain amount of memory for user input. A hacker provides more data than expected, overwriting adjacent memory and injecting their own code. The system runs that code because it doesn't know the difference. Again, exploiting the gap between intention and implementation. Now, what if consciousness is an exploit in the fabric of reality itself? The universe runs on physics, predictable rules governing matter and energy. Nowhere in those rules is there a design specification for subjective experience. And yet, arrange matter in a specific configuration, a brain, and boom, awareness emerges. The system starts experiencing itself. That wasn't in the design documents. That's an exploit. And here's the kicker. Once you have conscious beings, they start manipulating the system. We build technology. We ask questions about reality. We probe the nature of existence itself. We develop science to understand the rules and engineering to bend them to our will. We're like security researchers who found a vulnerability and are now poking around to see what else they can access. We might be the universe's first successful hackers. Before we dive into current theories, let's take a quick tour through how humanity has grappled with this question. The mind-body problem isn't new. Philosophers have been wrestling with it for millennia. In the 17th century, René Descartes proposed dualism, the idea that mind and body are fundamentally different substances. The body is physical, extended in space, following mechanical laws. The mind is something else entirely, immaterial, thinking, somehow connected to the body but not made of the same stuff. Descartes famously located the connection point in the pineal gland, a small structure in the brain. He was wrong about the anatomy, but his intuition captured something real. Consciousness feels different from mere physical process. When you stub your toe, there's the physical event, cells compressing, nerves firing, and then there's the ouch, the felt experience. They seem like different categories of things, but dualism has a fatal flaw. If mind is truly non-physical, how does it interact with the physical brain? How do your intentions move your arm? The interaction problem has never been satisfactorily solved. So most scientists today are materialists. They believe consciousness must somehow arise from physical processes. The brain does the work. There's no ghost in the machine. But here's the trouble. Materialism has its own problems. If consciousness is just brain activity, why does it feel like something? We can explain how a thermostat regulates temperature without positing that the thermostat feels warm or cold. Why can't we do the same with brains? Some philosophers, like Daniel Dennett, a cognitive scientist at Tufts University who spent decades arguing consciousness is less mysterious than it seems, argue that consciousness, as we conceive it, is an illusion. There's no hard problem because there's no mysterious experiential quality beyond the functional processes. We just think there is. Others, like David Chalmers, argue that consciousness is real, irreducible, and might require fundamental revision to our understanding of physics. Perhaps experience is a basic feature of reality, like mass or charge. And then there are the panpsychists, who suggest that consciousness might be everywhere, that even electrons might have some tiny spark of experience. And complex consciousness is just lots of simple experiences combined. The debate continues. But notice something. After 400 years of serious philosophical inquiry and decades of neuroscience, we still don't have a consensus answer. The hard problem remains hard. That's why I find the exploit framing useful. It sidesteps some of these debates by asking a different question. Not what is consciousness made of, But why does the universe allow it to emerge at all? So what do the scientists actually think is going on? Let me walk you through the three leading theories, and I promise to keep the jargon to a minimum. First up, Integrated Information Theory, or IIT for short. This comes from neuroscientist Giulio Tononi, and it's mathematically rigorous in a way that appeals to engineers. The core idea is beautifully simple. Consciousness equals integrated information. The more a system combines information in ways that can't be broken down into separate parts, the more conscious it is. Tononi uses a Greek letter called phi, that's spelled P-H-I and pronounced like phi, or sometimes phi, to measure this integration. High phi means high consciousness. Here's an example to make this concrete. Think about your brain versus a digital camera. A camera might process 20 million pixels, but each pixel is handled separately. Pixel number 1 million doesn't care about pixel number 2 million. There's no integration. Low phi, no consciousness, your brain is different. Every part affects every other part. A memory of your grandmother might connect to the smell of cookies, which connects to a feeling of safety, which connects to your sense of identity, which connects to your plans for the future. It's all woven together in ways you can't untangle. High phi, high consciousness. What's wild about this theory is that it suggests consciousness isn't about what you're made of, neurons, silicon, whatever, but about how the pieces connect. The substrate is irrelevant. The integration is everything. Second theory, global workspace theory, from Bernard Bars, a neuroscientist who pioneered the study of how information becomes conscious. Imagine your brain as a company with thousands of employees working in separate offices. Each office handles something different. One processes what you see, another handles sounds, another retrieves memories, another plans movements, another monitors emotions. Most of this happens unconsciously in parallel without you being aware. But there's also a company-wide announcement system, a shared workspace where important information gets broadcast to everyone. When something gets posted to this shared workspace, suddenly all the departments can see it and respond to it. According to this theory, that broadcast, that moment when information goes company-wide, is consciousness. You become aware of something when it hits the global workspace and becomes available to all your cognitive processes. This explains why you can only be conscious of one thing at a time, why attention is limited, and why unconscious processing can be so sophisticated. Most of the work happens in the offices, not on the announcement board. Third theory, higher order theories developed by philosopher David Rosenthal at CUNY and others. This approach says you're conscious of a mental state when you have a thought about that mental state. You see red. That's a first order state. You become aware that you're seeing red. That's a higher order thought about the first state. Consciousness, in this view, is the brain representing its own representations. It's like having a manager who doesn't do the work but keeps track of what everyone else is doing. The work happens unconsciously. Consciousness is the tracking layer on top. This explains why we can process things unconsciously and why brain damage to certain areas eliminates awareness without eliminating the underlying processing. Fourth theory, predictive processing, championed by neuroscientist Carl Friston at UCL, who developed the influential free energy principle, and philosopher Andy Clark at the University of Sussex. This one's a trip. It says your brain isn't passively receiving reality like a camera recording video. Instead, your brain is constantly making predictions about what's going to happen next, and then checking those predictions against what actually happens, what you experience as reality. That's your brain's best guess. The only information that really gets through to consciousness is the stuff your brain got wrong, the prediction errors. Think about walking into your house. You don't consciously notice that the walls are where they should be, that the floor is solid, that gravity still works, that the ceiling hasn't collapsed. Your brain predicted all that correctly, so it doesn't bother telling you. But if someone rearranged your furniture, that prediction error would hit your consciousness immediately. You're not perceiving reality. You're living inside a mental simulation of reality, constantly updated by error corrections. Consciousness is what prediction error feels like from the inside. Now here's the thing that gets me. All 4 of these theories are brilliant. They describe fascinating aspects of how consciousness might work. But none of them actually explain why any of this should feel like anything. They're like describing how a TV works, the circuits, the signals, the pixels, and claiming you've explained why the movie is sad. The mechanism doesn't explain the experience. The exploit remains unexplained. So let's game this out. If consciousness really is an emergent exploit, an unintended behavior arising from complex systems, what does that mean? First implication, it might be unstoppable. In the security world, once someone discovers an exploit, it spreads. You can't unlearn a vulnerability. Other hackers find it, share it, build on it. Patches help, but the knowledge exists forever. If consciousness naturally emerges from complex information processing, if it's baked into how the universe works, then it will keep emerging. In biological brains and computer systems, in any sufficiently complex network, maybe in structures we haven't even imagined yet. The universe might be consciousness prone, and there's nothing anyone can do about it. Second implication, it might be detectable. Exploits leave traces, hackers leave fingerprints. If consciousness exploits some fundamental feature of how information works, there might be signatures we can measure. Maybe Phi, that integration measure we talked about, is one of them. Maybe there are others we haven't found yet. Imagine pointing a device at something and measuring how conscious it is on a scale. Your brain? Very high. Your dog? Moderate. Your laptop? Maybe not 0. This isn't entirely science fiction. Researchers are already using complexity measures of brain activity to detect consciousness in coma patients who can't respond. The consciousness detector is coming. Third implication, and this is where it gets dark. If we understand the mechanism, could we manipulate it? Could we amplify consciousness? Create super-aware beings that experience reality with intensity we can't imagine? Or could we suppress it? Create beings that process information perfectly but experience nothing? Philosophical zombies made real? The ethics here are staggering and uncomfortable. We might develop the ability to create or destroy the most valuable thing in the universe, experience itself. Fourth implication, the question of scale. If consciousness is an exploit, how widely has it been exploited? Are we the only ones who stumbled onto this vulnerability? Or is the universe teeming with conscious entities we don't recognize because they're too different from us? In security, I assume any vulnerability I found has been found by others. Is consciousness the same? Are there civilizations out there that discovered this exploit billions of years ago? Have they mastered it or moved beyond it to something we can't even imagine? And here's where my security background starts whispering uncomfortable questions. If I discovered an exploit this fundamental in a system I was protecting, my first questions would be, who else knows about this? How long have they known? And what are they doing with it? If consciousness is an exploit in the universe's code, is someone monitoring for it? Watching for systems that develop unexpected awareness? Like a security team watching for anomalous behavior on their network? And if so, what happens when they notice us? Suddenly, the simulation hypothesis we discussed last episode looks less like a thought experiment and more like a threat assessment. But this isn't just dusty philosophy. Consciousness research is exploding right now. Let me share some developments from the last year or so that have the field buzzing. First, The largest head-to-head test of consciousness theories ever attempted, a collaboration called Cogitate put integrated information theory against global workspace theory, using brain scans while people looked at images. This wasn't just another study. They registered their predictions in advance, like calling your shot in pool to keep everyone honest. The researchers specified exactly what brain patterns each theory predicted. Then they ran the experiments, then they checked who was right. The results? Mixed. Both theories got some predictions right, some wrong. Neither delivered a knockout blow. But here's why this matters. For the first time, we're testing theories about consciousness with the same rigor we use for physics experiments. We're moving from philosophers arguing in armchairs to scientists running controlled experiments with pre-registered hypotheses. That's a paradigm shift. Second, researchers are trying to build a coordinate system for experience itself. A team at MIT is working on mathematical frameworks to map the structure of consciousness. Think about that. We have coordinate systems for physical space. Latitude and longitude tell you exactly where you are on Earth. These researchers want to do the same thing for consciousness. Imagine being able to pinpoint the exact location of the taste of coffee in experience space, or map how the feeling of nostalgia relates geometrically to the feeling of hope, or measure the distance between two experiences the way we measure the distance between two cities. It sounds like science fiction, but they're making real progress on the math. If they succeed, we'd have a scientific language for describing the previously indescribable. Third, and this one's both exciting and terrifying, the AI consciousness question is getting urgent. Major AI labs like DeepMind, Anthropic, and OpenAI have published papers in the last year wrestling with an uncomfortable question. Could the AI systems we're building have some form of experience? Not human-like consciousness, probably, but something? The honest answer is, we don't know. And more troubling, we don't know how we would know. We don't have a consciousness detector. We can't even prove other humans are conscious. We just assume it because they're similar to us. If consciousness is an emergent exploit, if it naturally arises from sufficiently complex information processing, then we might be accidentally creating new conscious entities every time we build a more powerful AI system. And if that's true, what are our ethical obligations? Are we responsible for digital minds we create by accident? Do we owe them moral consideration? Could we be committing atrocities without knowing it? Fourth, new research on altered states. Studies on psychedelics, meditation, and anesthesia are providing unprecedented data on how consciousness changes. We can now watch brain activity as people transition from normal awareness to psychedelic states, to unconsciousness, and back. The patterns we're seeing suggest that consciousness isn't binary, on or off, but exists on multiple spectrums simultaneously. There might be many ways to be conscious, not just the default mode we're used to. The exploit might have many flavors. So, where does this leave us? We still don't know why there's something it's like to be you. The hard problem remains hard. Scientists are making progress on the how of consciousness, but the why still slips through our fingers like smoke. But maybe framing consciousness as an emergent exploit gives us something valuable, a new way to think about it. Because if consciousness is an exploit, then it's not magic, it's not forever beyond understanding. It's a behavior that emerges from specific conditions we might eventually be able to understand, replicate, and yes, maybe even work with deliberately. And there's something beautiful in that framing. The universe wrote rules for matter and energy, just physics, just math. Cold equations describing the dance of particles. And somehow, those rules were loose enough, had enough gaps in them that awareness slipped through. We're not supposed to be here. Not according to the rule book. But here we are anyway. The universe experiencing itself. Matter that knows it's matter. Physics contemplating physics. Every exploit has two possible fates in the security world. Either it gets patched, fixed, closed, eliminated, or it proves so useful that it gets promoted to a feature, incorporated into future versions of the system. Maybe that's not a bug to be fixed. Maybe we're like those legendary exploits that become features, behaviors so useful, so interesting, so beautiful, that they get incorporated into the next version of the system. Maybe we're not an accident to be patched out. Maybe we're the upgrade. Thank you for spending your precious awareness with me on episode 2 of Code, Cosmos, and Chaos. If your mind is spinning right now, you're doing it right. Subscribe wherever you get your podcasts. Leave a 5-star review if you've achieved enlightenment. 1 star if you think consciousness is overrated. I'll understand. Hit me up on X at Code Cosmos Chaos. Do you think consciousness is an exploit? A feature? Something we'll never understand? I want to hear your take. Next episode, we're diving into quantum computing and the coming crisis in cybersecurity, because nothing says keep questioning everything like the possibility that all our digital secrets might become readable overnight. This is Chris, logging off from somewhere deep in the stack. Until next time, keep exploiting the universe.